Now that all three bug eye sets are working, there's two last things I want to do. First, I want to do an alignment on them, and second, I want to use a test pattern generator to adjust the linearity and the centering. To do the alignment, I want to try using this, which is a B&K 415 I recently picked up. Came in the original box and looks like it's barely, if ever, been used. I have not plugged it in yet, though. I don't know if it's working. It's solid state, I'd say from the 70s, judging by the look of things. All discrete transistors. Might even be late 60s, I suppose. I've been reading up on the manual, and I think I have the gist of how this works. So I've cleared some space on my shelf by taking out my B&K 1077. So I'm going to put this up there and plug it in and hook up a scope to it and see if it actually puts out some signals. If so, I'm going to start hooking it up to this guy, which is the second bug eye I restored. Just because it happens to be the one on my bench right now, then I'll do the same thing on the other two. The alignment procedure looks fairly straightforward. I'll briefly go through it once I've got the alignment generator up and running. Okay, I've got it plugged in, and I'm going to try switching it on right now for the first time. Keep your fingers crossed. I figure that's a good sign. Now these are pretty cool devices, not only in what they can do, but the way they laid out these controls. They actually show you a picture of what a typical IF response looks like and what a chroma bandpass would look like. Now this is just for color TV, so we won't be using this side of things for this black and white side, but we will use this side. Now what's cool is that these switches control the markers, and as you turn them on, if all goes well, these lights should be coming on. Let's see, 44, 45. They don't have lights here, so I guess those wouldn't come on. Or I should say 45 is, but there's no 44, and there's no 42.75, so these might be used for special purposes. But these, yeah, 45.75, 47.25, and doop, 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 doop. Alright. The chroma bandpass. I'm guessing you need to turn this on. Yeah, cool. One of these light up. So that would be your color burst. And then it uses phase modulation, I think, or something like that. So this would be where your color information is stored. But like I said, black and white set, so no matter. Alright, now this is for killing the AGC bus. You've seen me use these battery packs in the past where I just solder these into the set. Well, now I can use these very biased power supplies. Let's see, horizontal sweep. Okay, that goes to the scope. I'll have to see if I can dig up something that goes from one of these funky old style connectors to BNC jacks on my scope. Right, don't think, I'm not sure if we'll need the, let me think. Yeah, we'll need one of these, yeah, you either do DMOD or direct. DMOD has a detector diode in it, I believe, and this just has a direct signal. So this goes up to the X or horizontal input on your scope. This goes into your circuit under test. This goes to the vertical input on your scope, or the Y-axis. And this would be your output. This goes to your device under test. And attenuation control here. Some main function control. We're going to be doing IF first, so I want to have that on IF. This controls the center frequency of the sweep generator. This controls the sweep width. And this, I believe, does something similar to the markers on this guy. This, you can have a marker every 1 megahertz, 10 megahertz, or 100 megahertz. This goes a little bit finer. It puts a marker up every 100 kilohertz. So if I hook all this up to my scope and I flip this on, say I'm sweeping from 40 to 45 megahertz, I should see a marker at 44, 44.1, 44.2, 44.3, and so on. Every 0.1 megahertz. There's an empty crystal socket inside. You can, if you have a particular frequency that's not one of these, you can pop a crystal in. Also use an external marker. So I could hook it up to something like this leader and vary the marker frequency with this on this guy. So this is awesome for sets that use 44 or 45 megahertz IF, but about 90% of my sets do not. They all use the older 21, 22 megahertz IF. So, but for now, all the Bug Eye sets and all my Predicta sets use this IF. So for the time being, the 1077 is going to go probably up in the attic, and this is going to sit here, assuming it works. So enough talk. I'll try to dig up some cables, rig something up so I can hook this up to my scope. Let's see if we are actually putting out some signals. I looked through the box for the 415 and it turns out it comes with 3 cables. And that includes the most important cables, one being the output with the switchable attenuator for 75 or 300 ohms. So that's going to the RF output. 2 other cables I have. One is the demodulator probe. I imagine there's a detector germanium diode inside there. And the other one is just the straight. So just it's got that, I think they call those amphenol connectors, to just alligator clips. So those 2 correspond to direct and demod. So the one I don't have is this guy, well, these 2 guys, the amphenol to BNC. I think I've got at least one lying around. I'll go look in a moment. But right now I've got my scope hooked up to the RF output. One thing I want to know right away is, can this thing actually do a non-swept mode? The reason I'm curious is that, well, let's see, for the Bug Eye sets, purely visual. You hook up the sweep generator to various points and it should look like these various pictures. So you just tweak some coils and make the picture look like that. You know, the picture on the scope should look like that. However, for the Predictas, it says hook up a frequency of, say, 42.75, 44.75, 47.25, and adjust this coil for a minimum, adjust this coil for a maximum. In other words, I just want a precise frequency on the output, no sweep. In the past, I've used this with a frequency counter, but it would be so much more convenient if I can just flip one of these switches. So right now I do have it in IF, or sorry, I want to put this in marker mode. And what I'm hoping that means is, whatever marker I have flipped up, I get that frequency on the output. So let's go 41.25 for example. And crank this. That's good. As I crank it up, I'm getting a signal. And if I put this on time and frequency, I better go to cursors mode. There's a little bit of noise in there. About there. T2. About there. And yeah, it's about 41.25. I'll try a different frequency. 47.25. And T1. What this cursors mode does is it allows you to pick 2 points. I'm picking a point where the sine wave crosses the horizontal axis. So it'll give me the frequency between those 2 points and the delta time as well. And yeah, it's around 47.25 or 7.17, close enough. So yeah, this does work the way I expected. Awesome. Now if I go to IF mode, now it should be sweeping. Oh yeah, I can already tell. So notice how we have it's kind of clean in the middle, and as we go to the outsides it gets fuzzy. That's because it's actually sweeping the frequencies. And as I increase and decrease the sweep width, you'll see it. Right now the sweep width is at 0. As I crank it up, it'll get fuzzier and fuzzier. Maximum sweep width. Alright, so far seems to be working great. Changing the width center frequency now. Not much of a range though, so I probably won't really notice it change much. Alright, here's video mode, which I think doesn't keep the sweep width down. Not entirely sure what video mode does. I don't know if that puts out a test pattern or what. But I imagine you would feed this signal directly into the video amp. In other words, after the detector stage. Alright, I don't think we can check. Is if I hook this to this, we should see either a sine wave. No, I can't use this. I'll use the direct probe. I should see. I think it's a modified sawtooth. They use a varactor diode in this, I believe, for the sleep generator. And if they used a linear sawtooth, you would not get a linear sweep in the frequency. So they actually intentionally distort it a bit. So it sort of looks like a kind of a bent sawtooth wave. So let's see if that's the case. So disconnect this. Okay, scope's going to the horizontal output. Well, actually, it is fairly linear. Huh. Okay, so perhaps the output to the scope is linear, but internally they take this and they distort it and feed it to the oscillator. Now that I think about that, actually makes more sense. And then that's the retrace blip there. So, yeah, this does seem to be working properly. Alright, so I think I'm just going to go ahead and start hooking the sleep generator up to this guy. So the first step is you hook it up to point C. You'll have to figure out where point C is on the chassis. And they say to use a dummy antenna of 470 microfarad, which is picofarad. A dummy antenna is just a capacitor in series. So I'll take and solder one end of a cap to whatever test point C is and clip this to the other end. This goes to ground on the chassis. Also says to connect a short jumper from point A to chassis, so I'm going to find point A and ground it out. And then there's that bias I was talking about. Negative lead of a 6-volt bias applied to point B, positive to chassis. That's to knock out the AGC bus. So if you don't knock out the AGC bus, what happens is it sweeps and the signal level varies through the IF stages. It's actually going to modify the gain of the IF stages, and instead of getting a pattern like this, it's actually going to potentially just be a straight line, because it's going to compensate for losses in the IF by boosting the gain, and it's going to be fighting against this curve. So you've got to disable the AGC bus. And then I just go through and move the inject the signal at various points, and then do whatever it says. Adjust, for example, first step, adjust coils A1, A2, then A3, A4, A5, A6, and they tell you which figure to look at. I made all my connections as indicated, and I quickly realized that they're actually trying to be helpful with the way they set this up. For one, with this cone construction, you can access key circuit points from the back side. So for example, where this alligator clip is here, that's where you apply the negative 6 volts. Also notice there are little tabs coming out here and there near the tube sockets. Turns out those are the injection points. So one here, and there's one next to this tube as well, we'll get to in a later stage. So a little tab there I just tack soldered on my 470 picofarad cap, and that's where I'm feeding my signal in. And then the output for every part of the stage is through a 10K resistor to the last point down in there. And that is the video output. And I'd wondered why here and there on the chassis they were soldered these big heavy bits of wire, like tack welded to the chassis. And I realized those are very handy places to clip on the ground lead of your test probe. So, input, bias, output. And here's what we've got. Now the way they actually show it on the service diagram is upside down. Well, conveniently they give you controls for that. Vertical normal reversed, horizontal normal reversed. So if I flip that, there we go. Now as far as the horizontal goes, we should have 41.25 on the left. So let's go over here and turn on the marker. 41.25. It's right here. Can't quite tell if that's left or right, so let's try putting on 45.75. Let's see what that is. Okay, it's over here. So we do have the left-right orientation correct. And let's see. Does that look like that? Not quite. Let me scooch this down a little bit. One thing I have noticed that I don't think is working right on this generator is I've got the sweep width maxed out. It's supposed to have a maximum width of 10 megahertz. I've only got about a 2 megahertz width. I think it'll be enough. Because as long as I can see the markers and the key, part in here, I should be okay. So basically the two little lumps there, they should bottom out at those two frequencies, and they do not. The 41.25 is especially off. So this dip should be over here, and this dip should be about where it is. And I say to adjust A1 and A2. Well, as far as where those are, let's see. This diagram has been pretty helpful in setting all this stuff up to show you all those key points with all these labels around here. So let's see, A1 is... that's quite right. They actually show A1 pointing to one of the solder cups, so that's not right. It should be a coil. Wouldn't be the first time I saw a mistake on the schematic. On a SAM schematic, that is. Let's see. Oh, and A2's on the on the bottom side. Okay, so there's A2. It's that coil right there. So I'm going to get my little plastic alignment tools, try to figure out where A1 really is, and try tweaking these coils and see if I can alter the shape of that curve. Okay, I got that sorted out pretty quickly. This is A1 on top and A2 is on the bottom. Same coil with a slug on either side. I was able to figure it out pretty quickly because A2 is inside this metal box, and that's where the video detector diode is. So in other words, it's the stage right after this tube where I'm injecting the signal. So if I get my little twiddle stick down into that slug and tweak it, see, oh yeah, it's got a dramatic effect on it. No, never done an alignment before in a TV. Oh, this gets to be so much fun. Because you can see as I'm moving this around, I'm trying to get that lump, that dip on the left to be where that little marker is. And just from adjusting this slug, I'm not going to get there. I'm going to have to adjust this in conjunction with the one on the other side. And kind of go back and forth and back and forth and back and forth. So this can take quite a while to get everything to be quite right, because they interact pretty intensively. So, okay, let's leave that there. I'll try to get the tool in from the bottom, which is not easy because I get that metal box around the coil, and there's a metal support in the way, and there's a high voltage lead I don't want to get shocked by. Let's see. Alright, I think I'm in. Yeah. It's almost there. Back to the top side and tweak that a little bit, and it's the general process of doing an alignment. You get the right equipment, make sure it's working right, hook it up as indicated in the service notes, and go through and tweak the coils. Now if you don't happen to have these service notes, it's very, very difficult to do it. Every TV is pretty much different. Every model is different. There really is no general procedure to aligning a TV. AM radios, you can usually get away with inject a signal like at the antenna and just peak each coil. TV IF, totally different. You're trying to get a nice, big, wide, flat bandwidth going through this IF stage for the video signal. You're not just looking for a peak. You're trying to get like a flat plateau. And because of design compromises, you never quite get there. Usually you've got these two peaks with a trough in the middle, but the ideal is angle down, flat, and then angle back up. So yeah, I'll keep going through these procedures, and when I'm done, ideally we get a sharper picture and clearer sound. It took about 20 minutes of going back and forth between 4 different slugs, but finally I've got the waveform and the markers looking as close to that as I could make it. So I'm going to move on to the final 2 steps and then call the video IF portion done. Then I'll move on to the sound, which doesn't require any test equipment. It actually just says to tune to a station and basically do it by ear. You adjust these 4 coils for maximum sound and best quality, then you adjust the buzz control for minimum buzz.
Jury will convict us. Silence.
Here's a picture after the video IF alignment, and I think it looks a lot better. And now I'm tweaking the sound.
Guilty, Judge.
And as they say, just adjust these coils. So I just tweaked it a bit, now we got a buzz. I'm backing off a bit. Buzz is gone. I got too far. Get more buzzing again, so...
There's something fishy here. We better unmask that jury. Trace, sneak the dematerializer around your ghost pack.
I'm trying to remember what I'm doing.
I'll set the dematerializer on low
Alignment
voltage
tool.
and blow
There's the
away
coil.
those disguises.
I'm just doing it by ear.
They've got the dematerializer. Let's get out of here.
Do the same with this
We
guy.
can't let them get away. Let's go, Ghostbusters!
This one's a little bit harder to tell, so I'm just going to leave it about where it was. I think this is the last one. So that is a pretty significant effect. Fades away. Alright, cool. So, the last thing to do is get the test pattern generator.
Nope. Our job is to get rid of evil
I spoke too
spirits.
soon.
Send them into
One
limbo.
more
Can't
adjustment
bother
to
them.
make.
Then I was...
And that's the buzz
I
control.
must make up for it.
Is this guy.
Maybe if we worked together.
You bet. We can start right now.
No, Jake, it won't dematerialize him. He's too strong.
But it'll slow that bozo
There's
down.
buzz.
And now, my bratty little rodent, I'll show
buzz.
you how to deal with the ghost busters.
Now I'm done.
You think that dematerializer toy can bother?
I fired up my Sencor VA62 and I've got it going to the antenna terminal, set to channel 3. I've got the crosshatch pattern up. I've tweaked the vertical height and linearity and I think it's looking pretty solid. Horizontal's off a little bit on one side, but there's really no adjustment for that. And that's not too bad, I think. Here is the multi-burst bar sweep, which is an indicator of the bandwidth, and this is pretty good. These last two are 4 and 4.5 megahertz, which you're just not going to get because they limit the IF response on these sets. This is like up into the color information. That's why you see dots in here. In fact, that's like the the 3.5 megahertz color burst, I think. But these bars are really nice, crisp, and solid, so I'm really happy with the way this set turned out. I'm going to go through and do the same thing on the other two sets, but I'm not going to bore you guys with that. And once I get all three sets fully tweaked, my friend is going to bring over the cabinets. We're going to assemble all three and do one final video showing all three sets playing at the same time, hopefully. But for now, I'm just going to do one last segment with this set showing some over-the-air broadcast material. One last thing I did was manipulate the metal rings on the neck of the CRT for centering. I shifted the picture up a little bit and to the left a little bit. You may notice that the station identifying logo on the bottom right is a bit more visible now.
Was no fit companion for a boy who had. Well, yeah, something like that. Yeah. Well, that's life. Yeah.
You may notice there's a bit of buzz when some really harsh stuff comes on, like in commercials, or when the converter box logo comes on, but not much you can do about that. That's just part of the charm of vintage TVs. But otherwise, I think the set's working just fine.
You started messing with it.
What y'all did what?
Harold says you put your dirty hands on her. All right, come on.
Errors that each of us is prone to. That's why I'm not going to say one word about that cruddy wallpaper in the men's room. Did you crash the men's room?
Alright, so that's one down, two more to go.